Let's just dive right in. You know, when we're facing our biggest engineering challenges, we tend to look to the lab for answers. But what if the most incredible solutions are already out there? I mean, in the ocean, in the sky, even inside our own bodies. Today, we're going to explore a field that's changing pretty much everything just by looking to the natural world for a little inspiration.
It's a pretty powerful question, isn't it? I mean, really think about that for a second. The planet has basically been a non-stop R&D lab for, well, billions of years. Life has had to solve some unbelievably tough problems just to survive. So, what if we started paying a little closer attention to its answers?
And that's exactly what bio-inspired design is all about. It's this simple but kind of profound idea that we can learn from the materials, the structures, and the systems that nature has already perfected. It's less about reinventing the wheel and more about realizing, hey, nature already designed a masterpiece. We just need to figure out how it works. So where do we start? Well, our first lesson comes from the ocean and from one of its most efficient predators, the shark. Now, you might think the secret to a shark's incredible speed is a perfectly smooth surface, right? But it's actually the complete opposite. Its skin is covered in these microscopic tooth-like structures called denticles. They create these tiny little whirlpools in the water, which act like a sort of liquid ball bearing, and that actually reduces drag and improves lift. Pretty amazing.
And the real-world impact of this is just incredible. Engineers are now 3D printing surfaces that mimic these denticles to create way more efficient airplane wings, drones that can fly farther, and wind turbines that capture more energy. Just think about that for a second. A lesson from a fish is helping us master the air.
Okay, so from speed, we're now going to turn to dexterity. And for this, our next teacher is one of the most intelligent and, frankly, alien creatures in the sea, the octopus. This isn't about moving fast anymore. This is about mastering manipulation.
So on one side, you've got the old way of doing things. Rigid, metal robots that are super powerful, but let's be honest, they're often clumsy. They really struggle with anything delicate or oddly shaped. But on the other side, inspired by the octopus, we're seeing the future. These are soft, flexible robots that can bend and use suction to gently but firmly grasp pretty much anything.
And the result is a total game changer, especially for industries like manufacturing and logistics. I mean, just imagine assembly lines where robots can handle fragile electronics or package fresh fruit without crushing anything. That's the power you get when you start learning from a cephalopod.
So we've learned from sharks and we've learned from octopuses to improve our machines. But what happens when the machine we need to improve is the human body itself?
To solve some of the deepest, most profound challenges in medicine and mobility, where do you even turn for the most relevant, most advanced blueprint you could possibly find?
The answer? Well, it's us. The ultimate source of bio-inspiration for helping humans turns out to be the human body.
And this brings us to the incredible field of wearable and rehabilitative robotics, where engineers are literally taking cues from our own biology to help us heal, to help us move better.
Okay, so how does this actually work? Well, it all starts with biomechanics. That's just the study of how our skeletons and muscles move. Then, we combine that with advanced sensors that can monitor our bodies in real time. And finally, you have bio-inspired control, which basically means creating robotic systems that adapt and react naturally, just like our own nervous system does. The whole goal here is to create tech that works with our bodies, not against them.
And the applications are absolutely life-changing. By studying our own biomechanics, we can build exoskeletons that help factory workers lift heavy things without getting injured. Using bio-inspired control, we're making robots that help stroke patients literally reteach their limbs how to move. We can even read neural signals to control advanced prosthetics that mimic the super complex mechanics of our own joints. Every single one of these is a testament to what happens when we learn from our own biology.
Let's just quickly break down how this works. Step 1. Monitor. You've got advanced sensors that read your body's data, like muscle activity. Step 2. Feedback. That data instantly tells the device what you're trying to do. Step 3. Adapt. The control system, which is mimicking our own nervous system, adjusts its support on the fly. And the final result, Step 4, is this personalized assistance that feels natural and efficient. It's moving with you, not for you.
You know, all of this really begs the question, if we've learned this much already, what other secrets does nature still hold? The future of our technology is, without a doubt, going to be bio-inspired.
The key takeaway from all this research is pretty clear. Fusing biology with engineering isn't some niche field anymore.
It's actively building the future of human mobility and recovery. And this represents a huge shift in how we think about healing and assistance.
When you think about it, nature is really the ultimate open-source project. It's a library that's just filled with 4 billion years of tested, proven solutions. All we have to do is learn how to read the blueprints. So I'll just leave you with this question to think about. From building better materials to designing smarter systems, what problem, big or small, do you think we could solve just by taking a closer look at the natural world all around us? The answers are out there. They're just waiting.